Okay, so section 6.4 is called solving linear inequalities by using addition and subtraction. So basically what we're going to do is algebra, but just with inequalities and not with equations. So there's a few little rules you got to remember, but otherwise it's basically the same thing. So our learning outcome is to explain and illustrate strategies to solve single variable linear inequalities. All right. So in your notes here, it says consider the inequality -1 is less than 3. So what they've done here on the number line is they're showing you where -1 is. Right here. Here's -1. And then they're showing you where +3 is. So they're saying -1 is less than 3, which of course it is. It's on the left side of 3. So it says, what happens to an inequality if we add the same number to each side? Okay, so if we have -1 is less than 3 and we add 2 to each side, we take that -1 and we move 2 spaces to the right, or we add 2 and we get 1. So this one moved here. And then if we take that 3 and add 2, we end up at 5. Okay, so it doesn't matter if we add 2 to both sides. We still have the same, we still end up with the same thing, that 1 is less than 5. So it doesn't matter if we move them 2 spaces to the right or if we move them 2 spaces to the left. They're moving in an equal proportion or distance, so the inequality will still hold true. Okay, and then it says, what happens to an inequality if we subtract the same number from each side? So again, if we have -1, which was here, and which is less than 3, which is here, and then, well, what if we subtract 2 from both sides? So if we take that -1 and subtract 2, we end up at -3. If we take that 3 and subtract 2, we end up at 1. But again, same thing. We've done the same thing to both numbers, and -3 is less than 1. Okay, so the whole point they're trying to make here is the property of inequalities, that when the same number is added to or subtracted from each side of an inequality, the resulting inequality is still true. Okay? It's the same thing as algebra. Whatever you do to one side, you have to do to the other. So the strategy that we use to solve an equation can be used to solve an inequality. And again, you still need to isolate the variable in order to solve. So we have this example of an equation. Here's my unknown right here, r. Okay? And remember all the steps that we did to solve equations. So if we have r minus 6 equals -2, here's my line. To get rid of that -6, they are adding 6. Okay, right here. Do it to one side, do it to the other. So -6 and +6 makes it go away, leaving just r. When you have -2 plus 6, you end up at 4. Okay, so the only solution is r is 4, because 4 minus 6 is -2. Now remember what we talked about in the last section, that the thing about inequalities is there can be multiple answers. Oh boy, what is going on with my pen? Let's try again. See if it will let me write multiple. Not really. Multiple answers. Okay, so r minus 6 equals -2, or r minus 6 is less than -2. It's the same idea. Here's my unknown. And we're going to do basically the same thing. We have r minus 6, and we want to isolate this r. So again, they're adding 6 to both sides, just like over here in the equation. Okay, so -6 plus 6 is r. And then look at how this sign was less than, less than. The sign continues exactly as it did before. Same thing with the equals. We line them up. And we end up with r is less than 4. Now, r is less than 4. There's lots of things that are less than 4. Remember our number line. And if we put a 4 on our number line, we can't include 4 because 4 is not less than 4. So we have an open circle. But then we'd be talking about all the things that are less than 4, and that's this way. So if you can come up with anything that's less than 4, that fits our solution. Okay, and then in your notes, it says here that, well, hey, 3 is less than 4, 2 is less than 4, 1's less than 4, etc. Okay, so there's lots of different answers. And that's the thing about inequalities. You can have a range of answers. Okay. So the first example we're going to cover here says solve the inequality 6 is less than or equal to x minus 4, and then we're going to graph it on a number line. Okay, I know graph seems like we should be pulling out graph paper, but because we're putting on a number line, we still call it graphing. Okay, so we have 6 less than or equal to x minus 4. Okay, I still like that idea of the line. So put a line so that you can line stuff up. And where is the variable that we're trying to isolate? It's right here. Okay, so this is what we're trying to get by itself. So let's get rid of this minus 4. How do you get rid of a negative 4? Remember, you add 4. If you do it to one side, you have to do it to the other. So negative 4 and positive 4 go away. We have an x left on the right side. Transfer this symbol below. 6 plus 4 is 10. So this says 10 is less than or equal to x. So 10 is what goes on my number line. Put in 11 if that makes you happy. Put in 9 if that makes you happy. Okay, let's think about less than or equal. That's a closed circle at 10. So put a closed circle at 10. 10 is less than or equal to my answer. So since 10 is less than or equal to my answer is bigger. So it goes this way. So shade, highlight, color, whatever you want to do the number line going this way. Put a big old arrow indicating that anything along this line will make it true. Okay, so let's test 11. Would you say that 10 is less than or equal to 11? Is that true? Sure is. Okay, anything on this number line, including 10. 10 is the solution, because 10 is equal to 10. Okay, 10 less than or equal to 10? Yes. So 10 and to the right will satisfy this equation. Okay, so you try the check and pause here and then come back and see how you did. All right. So my inequality, p plus 3 is less than or equal to 4. Okay, I do not like what they've done here already. They should be lining stuff up. I don't like this at all, so I'm going to do this underneath. P plus 3 less than or equal to 4. Why does my pen draw those silly lines? Okay, I'm going to go slow. Let me try it one more time. P plus 3 less than or equal to 4. Okay, draw your line. Trust me on the line, it's helpful. Okay, here is my unknown, P. P has to end up by itself. How do I make P go be by itself? I get rid of what else is on that side. I have a positive 3. How do you get rid of a positive 3? You subtract 3. That's what they wanted here, but I don't like it all in the line like that. Okay, I like you to write it underneath. It makes a little more sense. So whatever you do to one side, you do to the other. So on my left side, plus 3 minus 3 goes away, leaving me with P. Transfer this symbol, and 4 minus 3 is 1. Okay, P is less than or equal to 1. 1 will have a closed circle because my solution says P is less than or equal to 1. Closed circle. Okay, where are numbers that are less than or equal to 1? On this side. So if you just like using your pencil, make a big thick line and indicate anything going this way will satisfy my answer, okay? Because, for example, 0. 0 is less than or equal to 1. Negative 3. Negative 3 is less than or equal to 1. Right, second example. Negative 5 greater than 2 plus a. Okay, what am I isolating? I'm isolating this a. Okay, draw your line. It helps with the left side, right side business. Okay, here's my a. I want to get it by itself. What's happening? It's being added to this 2. The 2 is positive. So how do I get rid of a positive 2? You subtract 2. If I do it to one side, I have to do it to the other. So the only thing I have left on the right side now is a. Take this symbol and transfer it down. Now, careful here. I have negative 5 and I'm subtracting 2. So I'm at -7. Okay. So, hold on. I don't have any room now on my number line. Let's see if I can move that down. Okay. So my answer is A, or -7 is greater or equal to A. So on my number line, I need a -7. I'm going to try to put that in the middle. Okay, what goes here if you want to? -6. Here would be -8. Again, not necessary, but you could do it if it makes you feel better. Okay, -7 is less than A. Open circle, because it doesn't include it. Okay, how can greater, not less than. -7 is greater than, because it wants to eat the -7. -7 is as big as it's going to get. Okay, so this is the biggest number, so we need numbers that are smaller, which again goes this way. So big, thick line, or your highlighter, because sometimes that's fun. Okay, everything on the left side is your solution, because -7 would be greater than -8. -7 would be greater than -10, etc. Okay, now what happens if we have variables on both sides? We got to be careful here, okay? So the first one says, or A says, solve the inequality 3D plus 2 is less than 2D minus 2, and we're going to graph it on a number line. So let's start off. I'm going to rewrite my question over here so I've got some room. 3D plus 2 less than 2D minus 2. Now, before what I did was I took a highlighter and I highlighted my variable. All right, now I've got variables on both sides. So this is going to be a two-step equation because I've got numbers and letters on both sides, and I need only letters on one side and numbers on the other. So let's deal with the D's. And I've got 3D on my left side, and I've got 2D on my right side. I can't have them on both sides. And I want to get rid of this guy. And the reason I'm going to get rid of 2D is because it's smaller than 3D. Okay? So I'm going to subtract 2D from my right side because 2D minus 2D makes it go away. Okay? Leaving just that -2. But if I do it to the right side, I have to do it to the left side. I can't subtract 2D from the 2 because they're not like terms. I have to subtract the 2D from the 3D. So I have 3D minus 2D is plain old D, or 1D. And then that plus 2 is still sitting there. Nothing's happened to it yet. Okay? Now I'm kind of like the questions I've done before. I've got a variable only on one side, but I've got numbers on both. Okay? I'm almost where I want to be. I need to get rid of this 2, because if I can get rid of this positive 2, I just have D on the left side, and then it's isolated. So I'm going to subtract 2 from both sides. So I have D by itself is less than, I have -2, subtract 2 is -4. So -4 goes on my number line. Open circle, because it's D is less than. Okay, D is less than -4. -4 is as big as it gets. So I am going to color this way, because here is where numbers are less than -4. Okay? All right. Now, what if I hadn't gone the other way? There's a little trick that I got to remember. Let me just make sure that I'm looking through. Did I go over that? Yeah, there's something I want to show you. Okay, I'm going to show you on one of these. I hate these lines. One second, I'm going to get rid of these lines. They are not helpful. I'm going to get rid of all of that. Give me some room. I know you wish you could do that on your paper. I wish I could do it on all the papers I have now. Okay. Okay. Now I want to show you something else. Okay. Let's draw my line. Here's my line. What if in this question, when I said that 2D is smaller than 3D, so I'm going to get rid of this on this side, and I'm going to have the D on the left side. I could have changed my mind, and I could have had my D's on the other side. Come on, go to the next page. There we go. So I'm going to try that here, and I'm going to show you, though, how it can make a difference. So this time, I have a 3Z here, and I have a 2Z there. And instead of getting rid of the smaller one on 2Z, what if I decide that I want to get rid of the 3Z? on this side. It's positive, so I'm subtracting, okay? Do it to one side, do it to the other. Remember that I can only subtract z's from z's. I'm not going to try to subtract 3z from 1. That's not possible. They're not like terms. Okay. So on my left side, I have 3z minus 3z, so that goes away, leaving just a 1 by itself. Transfer that symbol here. And then I have 2z minus 3z, which is negative 1z, or just plain negative z. You can put a 1 if you want to. And then that minus 2 is sitting there. Okay? Now, I have a negative variable. You have to remember there's something important that you have to do when you have a negative variable. Okay, my variable's here. So that negative 2 has to go away so that I can have my variable by itself. So add 2. It's negative 2, so add 2. Do it to both sides. So extend my line down. Transfer that symbol down. All I have left is negative z on my right side because negative 2 plus 2 is gone, or 0. And I have 1 plus 2 is 3. Okay, so I have negative z, and it might look like it's isolated, but it's not. You can never have a negative variable. It has to be positive, okay? So remember I said that you can think of it as negative 1z. Well, how can I make that negative 1 go away? Remember, it's negative 1 times z. So the way that I can make it go away is I can divide by negative 1, which would make it cancel out, leaving just a z. Okay, if I do it to that side, I have to do it to that side. So 3 divided by negative 1 is negative 3. Now, there's a big, big thing I want you to remember because we divided, div, we divided by a negative. And here's a math rule that you have to remember. When you are dealing with inequalities, if you divide by a negative, you have to switch the sign to the other way. Okay, I'll show you why in a second. So my answer ends up being negative 3 is greater or equal to z. And I'll put that on a number line in a second because it does say graph the solution on a number line, okay? Now you might be like, why do I got to do this? When I divide by a negative, why do I got to switch the sign? Okay? And it's got to do with this decision about which side my variable goes on. So I'm going to redo this question with you. And I'm going to show you the other way, okay? We'll get to this, and I'll make more room for this, don't worry. And you can just watch if you want to, or you can write this down, it's up to you. But let's start over. If I have 3z plus 1 less than or equal to 2z minus 2. Okay, there's my line. Now, I don't like worrying about dividing by negatives. I hate trying to remember this rule, although, you know, after 25 years of teaching, I can remember the rule, but you might not. So, you know how you don't bother remembering that rule? You do what I said before. You always get rid of the smaller one, okay? Because if I subtract 2z from both sides, look what happens. I have 3z minus, oh, that's a 2, my bad. 3z minus 2z is just z. It's not negative. Okay, it's positive. That plus 1 gets transferred. Less than or equal to 2z minus 2z gone. Negative 2. All right, how do I get rid of that positive 1? You subtract 1, do it to both sides. So I'm left with z less than or equal to negative 2, subtract 1 is negative 3. Now I did it a different way, but look at my solution. Z is less than or equal to negative 3. Negative 3 is greater or equal to z. Are these two answers the same? I've got my z on the other side, but look how the sign opens to the negative 3. The sign opens to the negative 3. Because I'm talking about a side of the number line, look, here's my solution. A nice line. There's negative 3. Close circle because it's less than or equal to. Negative 3 is as big as it's going to get. Negative 3 is greater or equal to z. So I want this side. My solution's this way. Okay, over here, z is less than or equal to negative 3. Again, I'm on this side. But if you are moving your variables on either side, like the equation, you would have to switch your sign or it wouldn't work. So if I hadn't switched my sign here and made it the other way, my answer would have been z is greater than negative 3. And I would have been over here, and that wouldn't have worked, okay? So there is this rule right here. Put it in your learning journal that when you divide by a negative number, you have to switch the sign direction. But you know what? I don't even bother trying to remember the rule because I always keep my variable positive. I look to both sides and I think, all right, what do I have to do to keep my variable positive? And what I do is I get rid of the one that will make my variable positive. All right, I'm not sure if you got that right because this was a check and I don't know if you would have known that rule. Now I've got a lot of mess here. So I'm going to clean this up so that I can do B. 1 second. Whoa. There's that. Not that. Okay, B. Let's get us back to the pen. Okay, so it says 4 less than 4x is greater than 6 minus 5x. Okay, draw your line. Now think about your variables, okay? So if I add 4x to this side, because it's negative, so I'm going to add. If I add 4x here, I'm going to have to add 4x over here. And negative 5x plus 4x is negative x. I still have a negative variable. I still have to worry about switching the signs. So you know what? Get rid of the smaller one, just like on the other question. I know 5 seems like it's bigger than 4, but remember negative 5 is smaller than negative 4, okay? So get rid of the negative 5x by adding 5x. Okay, negative 5 plus 5 is 0, and it makes it go away. If I do it to that side, I have to do it to this side. So I have 4. Nothing happened to that. I have negative 4x plus 5x becomes a 1x. Or just plain x. Transfer the symbol. This is gone, so I just have a 6. Now look at my variable's positive. I don't got to worry about switching signs. And that's how come I like to keep my variable as positive. Okay, get rid of this 4. How can I get rid of this positive 4? By subtracting 4. If I do it here, have to do it there. So I'm left with x greater than 2. Okay, number line, put a 2. Open circle or closed circle? Doesn't include open. Get out my highlighter. Okay, think about it. X is greater than 2. Here is where stuff's bigger than 2. So this would be my solution. Okay, so I know it's tricky about dividing by negatives. You got to switch your sign. So you know what? Avoid negatives. Avoid dividing by negative by not having a negative variable at all. All right, so good luck on 6.4. It can be a little tricky. You have the practice to do, and then your online quiz. There is no skill builder. Okay, good luck. Come and get help as you need.